So welcome to part 4, and thank you so much for joining me yet again. I have to confess to something. I'm filming this segment after I finished the filming for this part, and I had to delete the one I filmed before because it was full of optimism, and I have to be completely honest, this one was a bit of a nightmare. Watching this is probably going to be a bit like watching a blooper reel in a workshop. All kinds of things went wrong. Kind of, if it could go wrong, it did go wrong. And I have to say that part of it was, of course, added. The pressure was added because I was filming it, and I wanted to be honest. And when I screwed up, I wanted to keep it in. So you'll hear quite a lot of bleeping. There were times when I wanted to throw the whole thing out of the window, I'll confess, and I wanted to quit, thinking, you know, I can't do this, etc., etc. Anyway, watch it, and you'll hopefully learn by some of the mistakes I made. You beginners, you older hands will probably just find it quite funny, or not. Anyway, leave me your comments. Please subscribe if you're enjoying it, and here it is. So I need to be completely honest with you. I've had to break my own rules in this part. I came across something that was really stretching my abilities and my knowledge. Whoops, and the light just fell over. And that is that to make these clamps that go into here, so the reverse of the actual levers, you'll see that they have to slip in between these bars, and Harold Hall describes these cutouts that have to be made. And I didn't understand what he was saying about to shape fit to part 14 prior to drilling hole B, see head assembly drawing. It's not very clear. I mean, you guys might know exactly what he's talking about there, but I certainly didn't. I now understand, or at least I believe, that what I have to do is to actually fit the 60mm steel in the hole and then drill. I should have drilled those holes with that in place to make those recesses perfectly in shape. I think that's what he means. Anyway, I am skipping in this part because I did make a complete hash of it, and there's no point showing you all of that. I might show you little bits and pieces. But what I tried to do was to measure this very carefully with dividers, and then get it on the milling machine, and then try and mill the recesses out, etc. Anyway, no surprises, total rubbish, didn't work at all. So I've completely changed tack, and I'm going to drill through them when I've fitted them in here, through the existing holes. And in fact, I've done one and it seems to be working. But what I'm making at the moment, and this is what we're going to look at first, are these locking levers. So that's what we're going to work on. We're going to go to the lathe and do those in 3 parts. So the first part, oh yes, this is the other thing I forgot to say. In the diagrams, these are supposed to be 16mm, like the stock that goes in there, but I suddenly realized there's absolutely no point. There's no reason for them to be 16mm. And in order to make this really accurately, I want to avoid using the 3-jaw chuck in my lathe and actually use one of the fine collets that I have. The problem is I don't have a 16mm collet. I've only got a 15.5mm collet. So I've decided that I'm going to machine the 16mm rod to 15.5 and then do the rest of the operation in the collet. And the 3 operations are machining that to 15.5mm, then cutting that, and then tapering. And in fact, there's a 4th one, which is, of course, cutting the thread, the M5 thread on that. But first of all, I'm going to machine that to 15.5. Then I'm going to cut that, reduce that to 5mm. Then finally, when I've made all 3 of them, I'm going to taper that to 10mm on each side, so 20mm altogether. All right, let's get moving. The first thing I'm going to do is I'm going to mark off 20mm. Which is the length of the screw. I've faced that off to make it nice and clean, and I do this by starting the lathe backwards in reverse, which I find much easier to mark. Now back into the normal direction. I'm going to slightly change the angle on the tool post as well. Still half a mil to go. I shall probably stay there. To be honest, I'm probably going to keep it there so that I can tap it more efficiently. I'm going to do that. Make the tapping a bit easier. Okay. All right, let me set up for tapping. I'm really sorry. I know this is a terrible angle for what I'm trying to show you, but it's the best I can do with my setup at the moment. So I'm now going to cut a 10 degrees on each side, so 20 degrees in all. So I'll set it to 10 degrees here on the compound slide. Lock it well in place, and then I'll just reset up for the actual cut. This one I've got to be careful because it's easy to go past. See? Do I risk one more? Bingo. Okay, one more to do. So I've got another problem here. I need to drill a 5mm hole into this, and it's going to be perpendicular to this angle here of 20mm. And the truth is, I don't have any angle blocks, so I'm not going to go and spend 60 quid on a set of angle blocks. So I'm going to have to try and improvise a little bit. So what I've tried to do, and I'm going to describe it here, let me see if it works, is I've got one of these absolutely fantastic digital protractors here. And by the way, if you haven't got one of these, absolutely get one. They're cheap as anything, and they really make your life incredibly easier, especially when you're trying to grind cutting tools and things like that. If you haven't got one, get one. I zeroed it out on this surface here. This is the only way I know how to do it. It's completely mad, but if I try and get the square part on there, that is going to be perpendicular once I've got this angle exactly to 20mm. And the other thing is that is fractionally smaller than that. So anyway, it's completely mad, and I don't know if it's going to work. As you can see, it's really completely mad. But anyway, let me see if I can magic this at all. So if I can get an angle of 20, and I have measured this angle, by the way. It is 20. My lathe was beautifully accurate here. This is not likely to be anything like as accurate. You're probably all laughing at me here, going, "What the hell is he doing?" Wow. Bloody hard to hold as well. I'm feeling quite foolish right now, actually. I'll be completely honest. Okay, this isn't working. So just to show how things can really not go right sometimes, I took immense care drilling that hole at 20 degrees to the perpendicular, and it's come out perfectly perpendicular to the perpendicular. So, you know, there are times when you just have to go, all right, I can't do this very well. And I think the truth is that Unimat just didn't do it, and I'm really pissed off about it. But so what I'm going to try and do is, by hook or by crook, sort out my problem with the drill press. Otherwise, this is what I've got, and I'm just going to have to put these things in perpendicular, which doesn't look quite right for Harold Hall's design, but you know what, it's better than them not working. So anyway, that's where I am right now, and let's keep going. So of course, after having changed the compound slide, I want to make sure that that my slide is again completely straight, working towards for the drilling. So I think I've got it about right. That seems pretty accurate to me. A tiny bit of discrepancy. I think most of that is actually discrepancy in the steel that I've got in the thing. So I'm very happy with that. So from now on, I'm now going to take the 16mm steel and drill it all the way through, tap it all the way through to M5, and then cut it to size, and then drill it down through the top piece. I managed to break the drill inside the rod, so I'm now going to see if it's actually broken inside the rod or whether it just snapped. Whatever happens, either I will be able to turn it round or I will use another drill bit, but anyway, let's find out. Oh, I don't know if it broke. Anyway, let's find out. So now, without moving anything, I'm now going to put the M5 tap. Okay, M5 tap is now in. Put my foot on the clutch so it turns freely by hand. Now obviously the important part here is to start it straight. It's probably safer to then put it in a vise, and of course this slips because it's not designed, the tap is not designed to be in a chuck. So what I'm going to do now is I'm going to take all this out, put it in a vise, and then do it by hand. So I'm probably going to have to do this in stages, I now notice, because I'm not sure the tap goes deep enough. It's quite a long piece of steel, this. So what I'm going to have to do is to part the first piece and then get it to size, and then we'll do the second piece. So let me do that. So what I've done is I've now cut and drilled and tapped the clamps that are going to hold the locking levers on the other side. Here we have the locking lever and here we have the clamps. And so what I'm going to do now is that I'm going to drill through with a 10mm drill straight through and then cut that recess into them. I've loosened them a little bit because I want them to have a little bit of tension when I lock them. As you may have seen earlier, I did a proof of concept on one and they hold really well. So I don't have parallels that are long enough, so what I've done is a piece of silver steel, which is precision ground. So I'm very much hoping that that's going to actually do it. And then I'm going to drill through these and let's see what happens. Okay, your guess is as good as mine. Okay, let's see if this works. Happened there? The screw broke. I'll bet you any money the screw broke. That's the only way this could have happened. Oh my God. So I can't tell you how blue the air turned in this workshop just now. I thought I'd been very clever, and I thought that by clamping these two pieces through I'd get a perfectly good cut, and I certainly got one, but when I started doing the other one it obviously twisted and snapped. So I've got to make both pieces again. It's a lesson. Interestingly enough, when I super glued the piece in, it worked fine. When I held it in with a clamp, it snapped. I should have thought about that. I should have thought that this was not strong enough to take the torsion, I think it's called, or the twist. Anyway, here we go again. Jesus. Okay, so I've really had a bad day yesterday, as you probably noticed, and so I'm back today with renewed vigor, and I have really super glued these pieces in. They are really firm. The one down there, that one's already done, and this one here, they ain't gonna move. The biggest issue now is going to be to take them out, but I'm not taking any risks. So this one I have to drill both holes through it to shape that, and this one I have to drill one hole through it to shape that. So I'm going to take this out because otherwise the drill's going to smack into it at the bottom. And this time I'm also going to clamp the vise down to avoid any nasty surprises, or at least as much as I can on this thing. Okay, well, hopefully bingo. Let's find out. Okay, so there's a little bit of learning going on here. This is part 4, and I said to one of my YouTube buddies, Dimitris, who said, "Hey, it's looking really good." And I said to him, "Yeah, but now it's really going pear-shaped, as we say in England, or Pete Tong, as a lot of English people will know. I'm really screwing up in quite a monumental way, and I've become very frustrated, and I know that's part of the whole thing, but I wanted to share with you because I think this is part of what the channel is about. So the first thing that happened is this piece, right? So there are two 10mm pieces that come in here and one that goes in there, except I didn't look at the plans right. Those are 10mm, those are 12mm. That one is 12mm, and I didn't notice that. So I'm looking at the plans and I'm starting to look at part 5, which will be making the tap holders that are going down here, and they are all 12mm, and I was going, hang on a minute, what's that? Anyway, so I've had to re-drill this to 12mm. Now that sounds like okay, right? But it wasn't, because I've got these pieces that have to go in here, and I had to re-mill these basically, and that turned out to be a real pain in the ass, and it got jammed. I broke a drill bit, not a 10mm drill bit, I guess, a 12mm drill bit, but it's all gone very, very horribly wrong, and I got very cross. And then the next piece is, as you know, as you may have remembered from another part, I broke one of the clamps, and so I had to make another one. Of course, I ran out of 16mm rod. Fortunately, in my bin down here, I managed to find another piece of 16mm. I think it's silver steel, actually, not mild steel. But anyway, I got it down to 15.5mm, like I did before, to fit my collets, and I measured it all carefully, and I reduced this to 5mm, but I didn't do it very well, and it tapped badly, really badly. And so it's a complete waste of time. So I'm having to do things over and over again in this part. And I'm sharing this with you because I don't think I'm being particularly careless. I think things are just going wrong. I mean, mind you, the 12mm thing was careless. But anyway, right now I want to throw this thing out of the window. And I think it's perfectly acceptable to share that with you. Anyway, I'm going to start again. I'm going to reduce a 16mm bar down to 15.5 again, put it back in the collet, and start again. We will get there, but whether I've still got my sanity or not is a different question. Okay, so I've made the 3 locking levers after all my disasters, and if you remember last time, I tried to be clever and drill this to 20 degrees, or at least parallel to that surface on the angle, and it came out parallel to this one. So it's not the end of the world. I'll live with that, but I want to get it right for the next 2. So I did splash out in the end. I decided to buy some angle blocks because I'd like to make this right, and I'll see if I can make it work. So anyway, that's the next step. Alright, so I've got it on the 20 degree block. we should be okay. I've marked out the center line. The way I did that was I found out exactly the diameter, the width of these jaws, and this is halfway down, so hopefully that should work. And so let's use the center drill and the punch drill. Okay, and now we're going to switch to a 5mm drill bit. Okay, let's see if I can save the situation. Okay, I'm not taking any chances. That's going to be deep enough for me. I can't ruin another one. That should be deep enough to hold the rod. Okay, on to the next one. Well, by some miracle I've done it. So this is the one that went to the wrong angle, and this time, despite a hiccup, I managed to get the other two at the angle I wanted. So now I'm going to bond those in and file the ends and round the ends, and then I'll show you when it's done, and then I'll put the whole thing together, and hopefully it's going to work, because this one has really been a real pain for me, for no other reason that it's my lack of skill. Well, eventually I've done it, or at least I've done this part of it. There it is. It works so far. This episode, or this part, has been absolutely full of screw-ups. It's going to be my blooper reel, I think. I really hope the next stage, the final stage, which is to, I mean, this is just a dummy to make sure the clamps are working fine, and will be to make the actual pieces that hold the taps in the tapping stand. So that'll be part 5. And wow, this one's been a real adventure. I thought this was going to be a doddle, and it wasn't. Anyway, live and learn. It's been fun, and I'm glad it's done.